Funding for this program was provided by the Annenberg CPB project.
Additional funding provided by the people of Dow, the company that lets you do great things.
World-renowned physicist Wes Bassendale.
Oh, hi. I didn't see you there. I was just pondering the possibilities of distance, time, speed, velocity, and acceleration. You see, these can be broken up into two different categories. Categories of fundamental units and derived units. Fundamental units are what's measured. Derived units are found through multiple fundamental units.
Series demonstrator, Don Showalter.
Speed. Speed is a derived unit found from the two fundamental units, distance and time. Speed is found by dividing distance by time. Now let's see if we can find the speed of this runner. Let's watch. Wow, what a race. The runner's time was 11.4 seconds. To find speed from this information, we must first know the distance. The distance the runner ran was 100 meters. With this information, we can now find the speed. Speed is equal to the distance divided by the time. 100 meters divided by 11.4 seconds is equal to 8.77 meters per second. We now know the speed of the runner, but what about the velocity? Speed is scalar, meaning it just has a magnitude. Velocity is a vector, meaning it not only has magnitude, but direction as well. The runner was heading north, so we can say the velocity of the runner is 8.77 meters per second due north. Now that we know the velocity of the runner, we can now figure out his average acceleration. Average acceleration is equal to the final velocity minus the initial velocity divided by the time. Final velocity was 17.5 meters per second because final velocity is equal to the average velocity multiplied by 2 minus the initial velocity. Initial velocity was 0 because the runner started motionless, thus making the final velocity 17.5 meters per second. Now, average acceleration is equal to the change in velocity divided by the change in time, making the average acceleration 1.54 meters per second squared.
Keep track. I don't know, I was going to grab it. Yeah, they're technically not allowed to call offside.
Exactly how it is.
I'm filming you. Alright, now take a practice swing. Wait.
What you see here are 4 ping pong balls covered with foil. This is a glass rod. If you rub the rod with fur, it picks up a certain kind of charge, a positive one. Matter now can be charged in one of 2 ways. It can be charged positively or negatively. And the type of charge is very important. Let me show you why. If I take this positively charged rod and pass it near these balls, the charge is transferred to the balls, and look what happens. They repel. The balls are both positively charged, and positively charged balls repel one another.
When a negative charge is applied to the balls, the same thing happens. The balls become negatively charged and repel each other.
Now, what would happen if I took that negatively charged ball and moved it close to this positively charged ball? Let's try it and see. As we move them close together, look at that, they attract one another.